Let's move on. Test prep 8. Which of the following points is not a point of discontinuity? Is not a point of discontinuity for this function. So the first way is trying options. It is always a way, and the easiest way sometimes. Most of the time, actually, it's the easiest way. So x equals negative 1. Does it make the function undefined? Negative 1, negative 1. So negative under root will make the function undefined. So it is a point of discontinuity. So it is a point of discontinuity. What about negative 1 over 2? Negative 1 over 2, negative 1. Still negative under root. So it's also a point of discontinuity. Option C, when you try 0, 0 minus 1, minus 1 under root, it's also a point of discontinuity. Option E, option D, 1 over 2 minus 1. 1 over 2 minus 1 minus 1 over 2 under root. It's also a point of discontinuity. X equals 1. 1 minus 1. 0 under root. No problem at all. So 0 is defined under root. So it is not a point of discontinuity. So this way is the easiest way. No need to try to solve the question. Okay. What if you want to try? Let me show you the way. Second way. You're going to solve it in a long way. You'll find anti-domain. What is anti-domain? In order to find anti-domain, you should know what your domain is, right? So let's find your domain. So for square root functions, the domain is under radical being greater than or equal to 0, right? Isolate x, x is greater than or equal to 1. So this is your domain. Your anti-domain is its opposite. You change everything. X greater than or equal to will switched to less than. Okay, so x is less than 1 are points of discontinuities. They are points of discontinuities. X is less than 1. Negative 1 is less than 1. Negative 1 over 2 is less than 1. 0 is less than 1. 1 over 2 is less than 1. So all these options, numbers in all these options are less than 1 are points of discontinuities. But x equals 1 is not less than 1. So it's not point of discontinuity. Okay. So you'll solve the question by finding the domain first and reversing the result, you'll find anti-domain point of discontinuity. All right. Another question, test prep 9. So you can also try options. Let me try options first. First way, try options. So, over which interval does the function have point of discontinuity? So, from 0 to infinity, when you pick a number, 0 is discluded. For example, 1, 2, 3. It doesn't make function undefined. It is defined. So there is no point of discontinuity in this option. Option C, for example, between 1 and 2, let's say 1.5, it doesn't make function discontinuous, undefined. So it's no problem, no point of discontinuity. Option D, between 0 and 1, 0 and 2, like 1. When you use 1 back, 1 over 1 doesn't make any problem. From 1 to infinity, you pick any number that you want, 2, 3, 4. So it doesn't make function undefined, no problem. But in option B, you pick a number less than 0, including 0. 0 makes it undefined. Less than 0, let's say minus 1. Minus negative numbers make the function undefined. So discontinuity points are here. Negative numbers and 0 are the points of discontinuities for this function. So option B is true. Right? If you use the second way, you find domain first. So x is greater than 0 is the domain. Right? It's a square root. Normally it's x is greater than or equal to 0, but since x is in denominator, 0 is not included. So what about anti-domain? For anti-domain, you reverse Instead of greater than, you use less than or equal to. Okay, so this is where you have points of discontinuity. So only option B has this situation, x being less than or equal to 0. All right. Okay, there are similar mystery questions. You try it. Study Guide 29 and 2023, they asked a similar question. They just changed the number. Instead of 1, they make it 2. So how do you solve these kind of questions? You find critical values for top and bottom. For top, what makes the top 0? X plus 1, 0. X is equal to minus 1. What makes bottom 0? X being 0. So those are the boundary numbers. Let's use those boundary numbers in sign chart. Negative 1, 0. If we are finding point of discontinuities, then under root is negative, right? So those are the points where function is discontinuous. So let's complete the sign chart. If you pick a number greater than 0, like 1, 1 plus 1 over 1, it's a positive result. When you pick a number between negative 1 and 0, it's going to be negative. Pick a number less than negative 1, let's say negative 2. Negative 2 plus 1, negative 1 over negative 2, positive. So what are you looking for? Which region is your region? You are looking for point of discontinuities. So you look at numbers less than 0. So this is my region, the middle region. From negative 1 to 0. What about the parentheses? Is negative 1 included? If I include negative 1, it makes it 0. No problem. It's not point of discontinuity, so you disclude negative 1. If you put 0, is there any problem? Yes, there is a problem. If 0 is included, it makes the function undefined, so it is a point of discontinuity then. So from negative 1 to 0, negative 1 excluded, 0 is included. These points, this interval is the point of discontinuity. So if it comes in exam, you can try options too. Maybe this is confusing. Okay, another ministry question and study guide question. This is another type. There's trigonometric function in denominator. F of x equals 1 over sine pi x over 2. So what's the point of discontinuity? So it's kind of a rational function. So in rationals, what makes denominator 0 is the point of discontinuity. So equalize denominator to 0 then. Sine pi x over 2 equals 0. Okay, remember, whenever sine is equal to 0, the angle is equal to the angle, which is pi x over 2, is equal to n pi, where n is an integer, right? That's the rule. I need x alone. So let's do cross multiplication. So pi x equals 2n pi. Divide both sides by pi. Then x is going to be 2n, where n is an integer. So these are the numbers that make denominator 0. So these are the numbers that make function undefined. In other words, these are the function that makes function discontinuous. So those are x equals to n points of discontinuities. All right. So it doesn't matter what kind of function you have. You may have sine, cosine, tangent. You'll do the same. Okay, one last question and I will finish this topic. Which one is discontinuous at x equals 1? So in every option you have different types. In option C there is absolute value in denominator, option B piecewise, option A polynomial over polynomial, D also polynomial over polynomial. So I'm going to use the limit way because I can simplify C and B by using simplification techniques. So option A, limit as x approaches to what? 1 of the function equals, when you insert 1 back, what happens? 1 squared plus 3 times 1 minus 4. 1 plus 3, 4. 4 minus 4, 0. Divided by 1 minus 2, negative 1, negative 1, negative 2. 0 over negative 2, 0. So 1 doesn't make denominator 0. 1 is not point of discontinuity. It's not even point of discontinuity in option A. So it's not point of discontinuity. So no need to solve A actually, because 1 is not point of discontinuity. So we can't talk about the type of discontinuity since it's not. Option B. Option B, it's a piecewise function. Remember, for piecewise functions, to find discontinuity, we should check the limit. If the limit exists, then the discontinuity is removable. If not, it's not removable. So check both-sided limit. Limit as x approaches to 1 from left first. Negative 2 times 1 plus 2. Negative 2 plus 2, 0. What about right-sided limit? Limit as x approaches to 1 from right of x. When you insert 1 for x, it's 1. So 0 is not equal to 1. So limit does not exist since right and left-sided limits are different. Limit does not exist, so discontinuity is non-removable. Discontinuity is non-removable. So it's not our answer either. Option C, there is absolute value. Option C, limit as x approaches to 1 of 5 over x minus 1. When you insert 1 back, it's 5 over 0, undefined. So limit does not exist. That's not your answer either. So apparently your answer is D, because x squared, x cubed minus 1, you can expand this as x minus 1 times x squared plus x plus 1 over x minus 1. X minus 1s will cancel each other. So no more x minus 1 in denominator. So you removed discontinuity from the denominator. So your discontinuity is removable in the last option. Okay. I think I solved every type of question about point of discontinuity in the book and from the ministry. So the rest is